All right, before we start the notes, we're going to do a little warm-up problem just to practice what we learned yesterday. So I would suggest you actually pause the video, try it yourself, and then see how you did. Okay, we're sketching the graph of this parabola with the equation y equals the opposite of x squared plus 6x minus 8. And I hope you know that when you see the opposite of x squared, it's not the same thing as if you're squaring the opposite of x. Okay, so the negative is outside the squaring, not inside the squaring. Because it's a negative leading coefficient, this parabola opens down. To get the axis of symmetry and the vertex, we need to use opposite of b over 2a. And the opposite of b over 2a is going to be negative 6 over negative 2, and that's 3. So the axis of symmetry is the vertical line x equals 3. Always put the x equals there. And the vertex has an x-coordinate of 3. We need to substitute that into the function to find the y-coordinate. So the opposite of 3 squared plus 6 times 3 minus 8 works out to be 1. And then the y-intercept has an x-coordinate of 0, and so the y-coordinate is negative 8. So let's start with what we have. We can put that axis of symmetry in there, x equals 3, and we can put that vertex in there, 3, 1, and then the y-intercept 0, negative 8. We can reflect that across the axis of symmetry. And then to get a couple more points, remember from last time we had the over 1, up 1, over 1, up 1 thing. Instead, we're going to go over 1, down 1. So over 1, down 1 from the vertex and over 1, down 1 on the other side. We can also go over 2, down 4, over 2, down 4 in both directions. And now we have a nice set of points to connect. Oops, hopefully yours is not so squiggly. My hand doesn't like that angle apparently. Okay, next it refers you to page 244 for a graphing calculator activity. So let's take a look at an example from that page. Okay, so here's my graphing calculator, and in fact I'm just going to go ahead and reset my memory. Second plus, number 7 is reset, all RAM, number 2 is reset, just to clear out anything that may have been in there from before. Go to y equals, and I'm going to do the example that they work through in the book. So we have negative 2. Remember to use the negative button that's next to enter. Don't use the minus. Negative 2x squared minus 10x minus 5. We're going to graph it and find the maximum or minimum value. Wow, my voice cracked. That was cute. The maximum or minimum value. Now, which is it going to be? So, we have a negative leading coefficient, so it's going to open down, so it's going to be a maximum value. Let's see if our standard viewing window will suffice. So press zoom, and then number 6 for zoom standard. I think that gives us a decent enough view of the parabola that we can find the vertex. So the next thing we do is we go into the calculate menu, which is second trace. You choose number 4, maximum. And then you need to take your cursor to the left of the maximum. And once you're to the left of it, you press enter. Then you take your cursor to the right of the maximum, press enter. Your calculator might have put lines, boundary lines like mine did. And then you take your cursor between those two lines and press enter. Notice at the bottom of the screen you have the coordinates of the vertex. So the x-coordinate is about negative 2.5. And then it's the y-coordinate that we want. The maximum value is the y-coordinate of the vertex. So the maximum value is 7.5. So you could try a couple more from that page just to get the hang of it. And most likely I probably have a video tutorial on that topic as well. Okay, the next thing we're going to do is a quick review of yesterday's lesson. These concepts are so important and you're going to use them throughout the next couple of years of math quite a bit. So we just want to make sure we have them down. We have the standard form of a quadratic function, y equals ax squared plus bx plus c. And if the value of a is positive, it opens up. If the value of a is negative, it opens down. The axis of symmetry is the line x equals the opposite of b over 2a. And the vertex lies on that line. The y-intercept is the point 0, c. And I think under these boxes are just the things I already said. That bullet point talks about vertical stretches and shrinks. Okay. We also learned yesterday about maximum and minimum values. So if your parabola opens down, your maximum is the y-coordinate of the vertex. And if your parabola opens up, your minimum is the y-coordinate of the vertex. Now, to get ready for today's lesson, I want to combine what we learned in our last chapter about transformations with the basic parabola. So we're looking at y equals x squared, just kind of a very clunky calculator view. And we know that if we multiply it by 2, that's a vertical stretch, so the parabola will be 2 times taller. If we multiply it by 11.65, that's a vertical stretch, the parabola will be 11.65 times taller. If we multiply by negative 2, we have a vertical stretch, but we also have a reflection because of the negative, so it's 2 times taller and reflected across the x-axis. Same thing happens here, 11.65 times taller and reflected across the x-axis. If we go back to our parent function and we multiply it by a number that is between 0 and 1, if it's a positive, then it's a vertical shrink, so it's half as tall. If we multiply it by 0.1, another vertical shrink, 1/10 as tall. If we also have a negative, so if we multiply by negative 0.5, it's half as tall and reflected across the x-axis. And if we multiply by negative 0.1, it's 1/10 as tall and reflected across the x-axis. And then if we add numbers outside of the squaring, so if we start with our y equals x squared, and to that we add 3, or we add 5, we're adding positive numbers, it moves the graph up. If we subtract positive numbers, or in other words, if we add negative numbers, it moves the whole graph down. Those are vertical shifts or vertical translations. And then if we add or subtract, but inside the squaring, so x plus 3 quantity squared, x plus 6 quantity squared, so really what we're doing is we're subtracting a negative. Subtract negative 3. If you subtract a negative, it goes to the left. If you subtract a negative, it goes to the left. If you subtract a positive, it goes to the right. Same thing here. Those are horizontal shifts or translations. Okay, so let's start today's lesson. We are on notes number 16. Vertex form and intercept form. So we're going to have 3 forms. We're going to have standard form, vertex form, and intercept form. Vertex form is based on all of those transformations. So if you started with y equals x squared, and you stretched it or shrunk it vertically, or possibly also reflected it, you would be multiplying by some number a. If you shifted it left or right, you would be adding or subtracting some number, we'll call it h, inside the squaring. And if you shifted it up or down, you would be adding or subtracting some number, we'll call it k, outside the squaring. So vertex form looks like this: y equals a times x minus h quantity squared plus k. Now because we shifted the whole thing h units horizontally and k units vertically, the vertex is going to be hk. And the axis of symmetry, well, it contains the vertex, so it's going to be x equals h. So let's take a look at this example. Here we have an equation in vertex form. Y equals 1/2 times x minus 3 quantity squared minus 5. We're going to sketch it. We're also going to say if it opens up or down, what the axis of symmetry is. We probably should say what the vertex is, and 2 additional points. Now we don't have to do all that in order, so let's start with finding out whether it opens up or down. We still base that decision on the sign of the leading coefficient, and because 1/2 is positive, it opens up. Now to get the vertex, all we have to do is look at our value of h and k. H is 3, k is negative 5. H is the number you subtract from x, k is the number you add afterwards. So the vertex is 3, negative 5. So that means the axis of symmetry is x equals 3. So let's take that information and start sketching. Vertex is 3, -5. Axis of symmetry, x equals 3. Whoa, that's a crazy line. And then it's going to open up. And you know what? We can use that over 1 up 1 thing, except instead of over 1 up 1, it's over 1 up a half because we have that 1/2. So over 1 up a half, over 1 up a half in both directions. Over 2 up 4, nope, it's going to be over 2 up 2 because we go up half as far. Over 3 up 9, nope, over 3 up 4.5. Ooh, that means we have our y-intercept as well. So here's our sketch. And then for the 2 additional points, we could use a couple of the points that we just plotted, like 1, -3, 5, -3, and so on, whichever ones. It really doesn't matter. Okay, next let's talk about what's called intercept form. So intercept form is more of a factored form, and it looks like this. Y equals some number a times x minus p times x minus q. It's not really important that we use the letters p and q. They could be any letters. What's important is that it's factored, and your book uses p and q, so I figured I would just do that. Okay, so this kind of gives us a little foreshadowing to the factoring that we're about to do real soon in this chapter. The x-intercepts are going to be located at p0 and q0. So let's take a look at why that's true. I think I have a little picture here. So if something factors into a times x minus p times x minus q, if you wanted to know where it was equal to 0, because x-intercepts are points where the y value is 0, if you wanted to know where this equals 0, what you could do is set each factor equal to 0. That's called the zero product property. If you multiply 3 things and the product is 0, then at least one of those things had to be 0. So we have a equals 0. Remember, a is just a number, so that's not going to give us anything. We have x minus p equals 0. That's going to give us x equals p. And we have x minus q equals 0. That's going to give us x equals q. So that's where we get those x-intercepts. Now the axis of symmetry has to fall halfway between those points because a parabola has symmetry. So if you have 2 points with the same y-coordinate, the axis of symmetry is exactly halfway between those 2 points. So what's exactly halfway between p and q? The average of p and q, p plus q over 2. So x equals p plus q over 2 is the axis of symmetry equation. Now you don't actually have to memorize that. You can just find p, find q, and then average them. So let's do this example. Here we have an equation that is in intercept form. You see it's factored. We can find the x-intercepts. We can also find the vertex, axis of symmetry, and let's draw the graph. So to find the x-intercepts, we're going to set it equal to 0. We don't really need to do the 2 equals 0 part. In fact, we can divide both sides of the equation by 2. So we have x minus 4 equals 0. We have x plus 3 equals 0. So we get x equals 4. We get x equals -3. Okay, so our x-intercepts are the points 4, 0 and -3, 0. What's the average of those numbers? 4 plus -3 divided by 2 is 1/2. So the vertex is going to be 1/2 something, and the axis of symmetry is going to be x equals 1/2. To find the y-coordinate of the vertex, we need to take the 1/2 and substitute it into the equation. So 2 times 1/2 minus 4 times 1/2 plus 3. And that's going to be 2 times -7/2 times +7/2. And that works out to be -49/2, I believe. Hope I did that right. And that's negative 24.5. Okay, so we're going to have to think about that as we graph. This is going to open up. We want to have a y-intercept at negative 49/2. I'm going to have different scales on my axes. So I'm going to let my x-axis go by 1s, and my y-axis, I think, let's see, let's do this is 4. So that's negative 4, this is negative 24. Okay, so let's plot the x-intercepts. We have 4, 0, we have negative 3, 0. Let's plot the vertex 1/2, negative 24.5. And the axis of symmetry can be drawn in. And then we can also do the over 1 up 2, over 1 up 2, because we have a value of 2. So if we go over 1 and up 2, we're right about there and there. We can go over 2 up 4. Oops, how about over 2 up 8, because we're doubling. So that gives us some points. We have the x-intercepts as well. So there's our graph. Okay, I think this is the last one. Let's see. Yep, last one. So this is also in intercept form. So we have our negative 1 as the value of a. Since it's negative, it's going to open down. We can go ahead and set this equal to 0, and we'll find the x-intercepts. If it says intercepts, you should find x and y. So we'll set it equal to 0. We get x equals 0, and we get x equals 4. So the x-intercepts are 0, 0, and 4, 0. What about the y-intercept? Guess what? The y-intercept is a point with an x-coordinate of 0, so we already know 0, 0. Okay, so we have the intercepts. How about the vertex? Remember, to get the vertex, we need to average the values of p and q. So we average 0 and 4, and that's just going to be 2. And then if we substitute 2 into our equation, negative 2 times 2 minus 4 is negative 2 times negative 2, that's 4. So the vertex is 2, 4, we can plot that. The x-intercepts are at 0, 0, and 4, 0. We can plot those. The y-intercept is also 0, 0. And if you think about it, there's no vertical stretch, just a reflection. So from our vertex, we can go over 1, down 1, over 1, down 1. And that gives us a couple more points. All right, great. So here's your assignment. We're doing some every other odds, or EOOs. You do 1, you skip 3. You do 5, you skip 7. You do 9, you skip 11, etc. And I will post all of the solutions for you, just in case your book doesn't include some of them. I'll just give you a PDF of all of them. Thank you.